Ever felt like you're wrestling an octopus, trying to combine data from multiple tables? You're not alone. Bad joins can tank your database performance, leading to slow apps and frustrated users. But what if I told you there's a secret to making joins not just bearable, but actually fast? If you've ever built anything beyond a simple CRUD app, you know data lives in more places than one. Connecting those pieces efficiently is the bedrock of a responsive application. And honestly, it's where most devs trip up. Your users might forgive a buggy UI, but they won't forgive a slow one. By the end of this video, you'll master the core join types, understand the performance traps, and walk away with advanced patterns that'll make your database queries sing. The join jungle. Why joins are tricky. Okay, so, at its heart, a database join is about bringing related data together from two or more tables. Think about it. You have users in one table, their orders in another. How do you see John Doe's orders? You join him. Simple, right? Well, not always. The tricky part is deciding how they relate and what you want to keep. The biggest misconception I see is that all joins are created equal. They are absolutely not. We've got inner, left, right, and full outer joins, each with a distinct purpose. Using the wrong one is like trying to hammer a screw. It just won't work, or it'll break everything. Honestly, most of my early career join pain came from not truly understanding these differences. Inner join. The workhorse you already know, probably. Let's start with the inner join. This is your bread and butter. It returns only the rows where there's a match in both tables based on your join condition. If a user has no orders, or an order has no matching user, which, honestly, shouldn't happen in a well-designed system, they simply won't appear in the result. It's the most restrictive, and often, the most performant, because it filters out non-matching data early. Hot take. If you're using an older database, or just starting out, you might see from table 1, table 2, where table1.id equals table2.id. That's an implicit inner join. While it works, please, for the love of maintainability, use the explicit inner join syntax. It's clearer, less prone to accidental Cartesian products, and frankly, it just looks more professional. Modern SQL prefers explicit joins for a reason. Left join, the data explorer's best friend. Now, the left join or left outer join is where things get interesting. This one is my personal favorite for data exploration. It returns all rows from the left table and the matching rows from the right table. If there's no match on the right, you still get the left table's data, but the right table's columns will be null. This is incredibly powerful when you need to see everything from one side and then layer on related data if it exists. Here's the deal. A common, super useful pattern with left joins is finding records that don't have a match. Want to find users with no orders? Simple. Left join, and then where orders.id is null. This is a classic trick, and honestly, once you get it, it opens up a whole new world of data querying. I've seen so many junior devs try to use subqueries for this, and while it works, the left join is null pattern is often way more readable and performant. Beyond the basics, other joins and their niche. Alright, let's quickly hit right join. Think of it as the mirror image of a left join. It returns all rows from the right table and matched rows from the left. Honestly, I almost never use it. Why? Because you can almost always rewrite a right join as a left join by simply swapping your tables. It's a bit of a legacy thing, and I genuinely think it makes queries hard to read, because most people are used to thinking left or right with their primary table. We've covered the basics, but here's where it gets really interesting. How to make these joins not just work but fly. Stick around, because the next sections dive into the performance secrets and advanced patterns that separate the pros from the rest. Then we have full outer join. This bad boy returns all rows from both tables, filling in nulls for any non-matching records on either side. It's powerful, but also the most expensive in terms of results, potentially giving you a massive data set. You'll typically see this in data warehousing scenarios or when doing complex data reconciliation, not usually in your day-to-day application queries. It's a tool for specific, often diagnostic jobs. Quick side note, self-joins are another beast. This is when you join a table to itself. Sounds wild, right? But it's super useful for hierarchical data, like an employee table where each employee has a manager, and that manager is also an employee. Or finding friend of friends. You just alias the table twice and treat them as two separate entities. It's less about a new join type and more about a join pattern. Performance patterns. Don't shoot yourself in the foot. Real talk. A poorly optimized join can bring your database to its knees faster than almost anything else. The number one thing you need to care about? Indexes. If you're joining on a column, especially foreign keys, and that column isn't indexed, you're essentially forcing the database to scan entire tables every single time. That's an O in asterisk M operation in the worst case, which, trust me, scales terribly. I once debugged a report that took 3 minutes to run, added an index, and it dropped to 2 seconds. Wild, right? Another subtle but important point is the order of joins, especially when dealing with multiple tables and filtering. While modern query optimizers are smart, sometimes helping them out doesn't hurt. Generally, try to join to smaller, more restrictive tables first, or apply your where clauses as early as possible. This reduces the dataset size that subsequent joins have to process, minimizing intermediate results and memory usage. It's a small optimization, but it adds up. Unpopular opinion. Sometimes, denormalization is your friend. I know, it's heresy in the relational world. But if you have a piece of data, like a user's username, that's constantly being joined from a users table to an orders table for display, and that username rarely changes, duplicating it in the orders table can significantly speed up reads. The trade-off is increased storage and more complex writes. You have to update in 2 places. It's a classic memory versus speed trade-off, and you need to weigh it carefully based on your read/write patterns. Don't do it blindly, but don't dismiss it either. Advanced join patterns, the real magic. Okay, so you got the basics down. Now for some real wizardry. Common table expressions, or CTEs. These let you define a temporary, named result set that you can reference within a single query. Think of them as subqueries that you can reuse and that are often more readable. When you have multi-step joins or need to pre-filter data before a complex join, CTEs are a lifesaver. They break down a complicated query into logical, manageable steps. This frustrates me when I see nested subqueries that could easily be a CTE. Still with me? Good. Another pattern worth knowing is the exists operator. Sometimes, you don't actually need to return data from a join table. You just need to know if a related record exists. Instead of an inner join that might bring back many duplicate rows from the left table, exists is often more efficient. It stops scanning as soon as it finds one match. It's a subtle distinction, but in large data sets, it can make a huge difference in performance, especially if you're only checking for presence. Real-world scenarios and gotchas. Okay, let's talk about many-to-many relationships. This is a classic. Think students and courses. One student can take many courses, and one course can have many students. You solve this with a join table or pivot table in the middle, say student underscore courses. To link them up, you need two joins. It's not complicated, but it's a pattern you'll see constantly. And honestly, it's a beautiful example of how relational databases model complex realities. Finally, let's touch on the N+1 problem. While not strictly a SQL join issue, it's a performance killer that often happens because of how we fetch related data. Imagine an ORM fetching 100 users, then for each user, running a separate query to get their orders. That's one select for users plus 100 select for orders equals 101 queries. Yikes. The solution? Eager loading or pre-fetching related data, often using a single join to pull everything you need in one go. If you're using an ORM, learn its eager loading patterns. They're usually called include or with. Let's recap. We broke down inner, left, right, and full outer joins, understanding their distinct purposes. We explored critical performance factors like indexing and the subtle impact of join order. And we tackled advanced patterns like CTEs, the exists operator, and common pitfalls like the N+1 problem. The key takeaways: always use explicit join syntax for clarity and to avoid accidental Cartesian products. Index your join columns. It's the single biggest performance gain for most queries. Choose the right join type for the job. Left join for exploration, inner join for strict matches. Consider CTEs for complex queries to improve readability and modularity. Be aware of the N+1 problem in ORMs and use eager loading to fetch related data efficiently. If this helped you understand something new about database joins, consider supporting the channel. Every bit helps keep these videos free for everyone. Drop a comment with your thoughts or your biggest join-related headache.